With a wealth of experience in cybersecurity, including expertise in threat analysis, network architecture, and risk management, our speaker has left an indelible mark on the field. A major of Delaware Army National Guard and a certified information system security professional, he is also a senior network engineer and a principal operations officer for the 198th Expeditionary Signal Battalion Enhanced. In addition to his professional pursuits, he enjoys spending time outdoors, reading, and engaging in family activities like playing Minecraft with his children. Today, he will delve into a topic of utmost relevance. All your language are belong to us. Implications and effects of large language models for cybersecurity. Please join me giving a warm welcome to Mr. Mike Willburn. He'll be joining us virtually.
Thank you, everybody. I'd like to first thank the University of Colombo for the opportunity to present the keynote speech at ICT ER 2023. My name is Mike Willburn, and I work for the MITRE Corporation. You might be familiar with the MITRE Corporation as the producers in cybersecurity of the attack framework. MITRE Attack and Defend are fairly well known as a framework in which you can model threats, really very technically detailed, getting you through the entire life cycle of attackers and all the way down to currently known and pre-archived threat operators in the world. So MITRE, as a company, does a lot more than just MITRE Attack and Defend. We're working on behalf of the public good. We are a not-for-profit organization in the United States. We started in the late 60s, and we've been doing cybersecurity pretty much for the whole time there. The MITRE Corporation does a lot of other things as well, but we are definitely well known across the world for our cybersecurity expertise. We tend to work with the United States government on behalf of government sponsors. I also want to say that I'm thankful to the U.S. State Department, who's the sponsor for this project, and to SL CERT for connecting us with the University of Colombo in order to make this opportunity happen. Very grateful to be here with you this evening. So I want to point out that the first sentence on my slide, "All your language or belong to us," is actually intentional. This is going to come up a little bit in what we're going to talk about for the rest of this this presentation. While it's a reference to a video game that I've actually played. It came out in the early 90s. It was developed in Japan, and the translation, I mean, if any of us have used Google Translate at some point in the past, I know that's much more recent than the early 90s when this was translated, but we've probably run into interesting translation errors that have come across. And that is something that has an implication for cybersecurity moving forward, and I'll get into those details in a little while. I also want to thank my co-authors, Zachary Silva and Alex Brayman, who worked with me on developing this, and they put a lot of time and effort into it. And it was a lot of fun, and a lot of very interesting things came out of the work that we did. So here's our quick agenda. I'm going to introduce us to large language models. I'm going to talk about a little bit about our artificial intelligence, machine learning, what those things are, why they're a cybersecurity concern, provide the use cases that my colleagues and I put together, and then we're going to talk about what we can do as cybersecurity professionals. And then we'll have some time for questions and discussion at the end. So a little introduction of myself. Um, I've been doing cybersecurity for uh, close to 15 plus years. I started out working in cyber threat intelligence, and so studying the threats and capabilities that threat actors would use as far as cybersecurity. I've been working with the U.S. military for a very long time, up until recently, and then also have done cyber threat intelligence with MITRE on a couple of different occasions for a couple of different projects that we've done here. In addition to my background in cyber threat intelligence, I'm a network engineer. I've been doing that um, for about 8 years now, uh, developing networks and more on the level of similar to what ISPs provide, the internet service providers might provide to um, uh, those sorts of high level network architecture. But I've also built a few interesting enterprise networks and had a lot of opportunity to work with satellite communications and RF communications. And most recently, I started working on artificial intelligence and machine learning projects with MITRE, and I've been doing those for close to 4 years now, uh, building machine learning models, defining artificial intelligence, looking how we can leverage machine learning models for safety and security in several different fields of opportunity to include to include and especially across cybersecurity. But so that's a little bit about me. It's a little bit about where I come from and what brought us here. What we're really here to talk about though is these large language models. So large language models was not something that was typically talked about in artificial intelligence and machine learning up until really late 2022. So it's where we're coming up on about a year now since the large language models have really become an important topic that we see in the news all the time. You may know them as Chat GPT, Google Google Bard, um, and other. Let's see, the one from Meta is called Llama. So several different large language models have started to come into the news, and we've started to hear a lot about them in about the past year. And the reason is because for a long time in artificial intelligence and machine learning, we have been working towards what's called natural language processing, which is the development of a model that can really take in natural language. Specifically, for the most part, it's been done in English. Now, it does apply to some other languages, but it has primarily been done for the English language. Um, Natural language process of ingesting information similar to how a human would ingest it, being able to then respond in also a natural way to the questions and prompts that are posed to it. Um, so, how do they do that? And what makes large language models special is really the next things that we're going to talk about. So, before I get specifically into large language models and what makes them really special, we want to talk a little bit about machine learning so that you understand where all of this is coming from. So, machine learning is kind of a large topic that gets a lot of different uh, attention throughout the news media, the scientific community, the cybersecurity community. A lot of different places are talking about machine learning and how do we incorporate machine learning into business? How do we leverage it to uh, do better things, better analytics for global warming, for climate change? How do we leverage machine learning in order to provide better healthcare? How do we use it? And it's getting a lot of attention over the last 10, 15 years or so, we've developed algorithms in order to train these models that have really made them quite powerful tools uh, across many different disciplines. One of the key things there, though, is that all machine learning models are based on data, lots of data. So some of the models that I've worked on in the past for some of the smaller models that were kind of more prototypes, that were really not very sophisticated, had even still as many as 25,000, 50,000 different parameters and data points that they would be using in order to train the model. And so and that's really considered not enough data to really get to a good and highly accurate model. The best models have hundreds of thousands to millions of parameters. What we're seeing with large language models is a shift in orders of magnitude on the amount of data that they've been able to ingest. Another important point about the data is uh, you may be familiar if you've been working in with computers and for any period of time with there's an adage, we call it garbage in, garbage out. So if the data that you feed to a model is inaccurate, or if it is in any way uh, kind of corrupt or not enough, or it's skewed to a certain direction, uh, all of that's going to come out in the model. The model's not going to fix that because the model's still just an algorithm that's run by a computer. It still runs just like any other program that you'd write line by line through the training program, through the algorithm. Uh, it's got a it's got some very interesting ways that it makes connections across those, which allows these statistical models that come out of machine learning to be really very interesting in a lot of ways. And when I say interesting, either they're extremely accurate in some of the things that they're able to predict, or they come up with potential answers, solutions, possibilities that it would have taken us as humans a very long time to come to. Um, and crunch through lots of data really fast because computers are very good at going through lots of data really quickly, especially with the advent of things like GPU processing and things. Um, so, you've got hyper-threading in CPUs. You've got large clusters of supercomputers, and now more locally and throughout the world, there's been an explosion of the use of the GPU because of its ability to ingest mathematical data, crunch it, and turn out different results. Now, in machine learning, we're specifically looking at statistical models that it's trying to get to, where we have these really extremely large data sets, and we're trying to find the most important and useful information that we can out of those large data sets. GPUs and other things have been also used in things like cryptocurrency and blockchain technology, uh, and other things because they're so good at processing this data very quickly. But one of the key point about this is that the data that goes into a machine learning model really needs to be curated. It needs to be uh, paid attention to, and the developers who are developing a machine learning model really need to pay attention to the types of data that they're feeding to their model. Otherwise, they're going to end up with a model that's skewed entirely one direction. Maybe it has like a skew over two directions, or maybe it's just random noise. Or in the worst case scenario, usually for what they're trying to do, is with a machine learning model, you're always trying to build a tool to accomplish a certain effect at the end of the day. Just like when you're developing any computer program, you're developing the computer program so that it does have certain functionality. So the machine learning models, you're as a developer, we develop them so that you can use them to solve certain problems and apply them in certain ways. And if our data is not accurate, then we get inaccurate results. The model doesn't do what we wanted it to do, and we have to go back and we have to look at what's going on. Use more often than not, you have to be very careful. We have to look at the data again and say, well, there's a lot of bad data here. We need maybe a different data source. We need to find other data, and that can be an expensive part. One of the most expensive parts of developing a machine learning model was actually finding good data and curating it. And most machine learning models are also very use case specific because you're developing a very specific tool to accomplish a specific task or to analyze specific certain types of data sets. So machine learning models are very, very powerful tools that we've developed. We've been talking about natural language processing and artificial intelligence uh, really since the beginning of the computer with Alan Turing, and he kind of coined that term artificial intelligence a little bit. It's definitely associated with a lot of his early work. But anyway, ever since then, people have been trying to accomplish things that we've only been able to realize in the last 10 or 15 years with machine learning. Um, Training those models can look very different depending on the type of data you're trying to analyze. So, in the case of language, for natural language processing, it's often what you're trying to do is make some sort of an association map between words. So, if the first word in the sentence is um, hello, what is most likely to follow after that? What's the next word that's most likely to come next? And with a machine learning model, you develop an algorithm to run through a lot of different data sets in the English language to look at the word hello and what follows it. And then it can start to make those associations with, some sort of percent accuracy. Then the word after, if the first word in the sentence is hello, what should be the second word in the sentence? And as a programmer, I would say hello world, right? Because anytime I start writing, learning a new language or doing things like that, that's the classic program that we write as programmers is hello world. It's really very simple usually to implement, but it does kind of help us to understand the languages that we're working with. Um, a type of algorithm out there is called deep learning, which actually iterates the machine learning model, the data, and the associations made through it through several different layers of training, and then there's associations between each of the layers, which really starts to develop these very sophisticated, deep understandings of the data that you're analyzing in machine learning, and that has been kind of the one of the powerful tools that have come out of it. Part of my background is I actually started not in cybersecurity, but in chemistry a long time ago, and have a master's degree in biochemistry where I studied proteins and enzymes and how they function in the body, how they move, and how that contributes to their function. Now, machine learning has been able to take a lot of the data points in things like the study of chemistry to uh, find new and interesting paths of study through which chemists can then go and do experiments and things that may not have been thought of for some time, or it probably would have eventually come to it, but machine learning was really accelerating the pace at which these ideas are coming forward. Um, Machine learning models were used during the COVID-19 pandemic in across fields, whether that was healthcare or biochemistry, and many other fields, to really help us deal with some of the effects and hopefully speed up the development of vaccines and vaccine distribution problems, things like that. Um, a Another key point in training is that the training of a machine learning model can either be what's called supervised or unsupervised. If it's supervised, you have a programmer, a human somewhere. Well, a human really is watching pretty much all of the training going on, making sure that as you train it, you're double checking exactly what happens on the back end of it. It can be a slower process because uh, basically you're kind of watching the program run. It's almost like watching a debugger in some ways when you're writing programs. Versus unsupervised learning takes place when you allow the model to just kind of continue to iterate through its algorithm, uh, really until it comes to some completion point where you tell it to be done, and then you look at what happens at the end of it. The other thing with unsupervised learning that you can do that really kind of helped to get to these large language models and generative AI that you might are terms that you might have heard. It started is generative adversarial networks, or GANs, is a type of algorithm that people can use, type of training algorithm that has been used to great success. And what that is in like data classifiers, where you're trying to tell, is a picture of a cat, or is it a picture of a banana? And you show the way you train the model is you associate the word cat with true pictures of cats, and the pictures of bananas with true pictures of bananas, and you have one model that's learning that. But then you also have another model over here that is learning how to make pictures of bananas and make pictures of cats. And then you'll have the one model create a picture, and the other model, the classifier, will look at the picture and say, this is a cat or this is a banana. And there'll be some certain percentage how accurate it is. And if it creates, if the picture is, and so, and then once it knows whether it was right or wrong, whether the picture was a cat or a banana, then it'll get feedback to that model, and that model will be like, oh, okay, well, I was right, okay, that's good, so I'm going to keep that in my in my algorithm, and we're going to keep moving forward. Or no, I was wrong, so I need to learn uh learn better the difference between the cat and the banana. But on the other side of it, the one that's generating the pictures of the cats and the bananas also learns how well it can fool, or how how good its pictures of cats or bananas are, so that the other one, and it kind of becomes this game back and forth between the two models. But really, what they do is they build on each other, and they make these really highly sophisticated, very interesting statistical models that come out of that. Uh, so we've talked a lot about several of the use cases, specifically cybersecurity. We want to talk a little bit about threat modeling, right? We started out talking about how we do MITRE attack and defend. One of the tools that a lot of cybersecurity professionals are looking at right now is how do we leverage artificial intelligence, machine learning, to really detect when there's anomalous behavior, when there's unusual behavior on our networks. Because that's one of those things that if you don't have an analyst sitting there watching it all the time who's used to what the data looks like, it's hard to tell when, if there is a problem going on. And so if we could train a model to recognize when something unusual is happening on our network, we may be able to react even faster, and be able to mitigate the problems that are coming through sooner. That's just one example of possible uses in cybersecurity. We talked about the research that was done for COVID-19, some of the things that I have done personally with biochemistry and proteins. And then ultimately, because you're building statistical models, anything that can use statistical models to improve workflows really can benefit from machine learning. So that includes, economics, stock exchanges, logistics and shipping. How do you get packages from one place to another most efficiently? And they've been used to good effect, and they've also been used to there have been mistakes that have been made with artificial intelligence throughout the entire process. But these are the things that people are doing with it, and that's kind of a background on machine learning. That's all so that you understand when we're talking about a large language model, really what has to go into this. So we talked about lots of data before, and how much data is required for a standard machine learning model. But with a large language model, we're talking billions and billions of parameters. So Chat GPT 3 and 3.5 were trained on over 4 billion different parameters. So this is 3 orders of magnitude more than a lot of the natural language processing models that had come previously. Where the amount of data is just staggering how much they were able to use in order to train these models. And GPT-4, I believe, we're looking at over 6 billion or over 8 billion parameters. The numbers of parameters are just going higher and higher. Now, where do they get the data from? That's an important question that maybe some of you are asking. The data comes from the internet. Um, there's a lot of different sources out there that are open, public information that they've been pulling from in order to pull in all of these billions and billions of parameters in order to train the models on. And there is concern, both among people who are trying to protect intellectual property, people who are concerned about privacy, us in cybersecurity are concerned about where that data comes from and what happens when you pull all that data together. Are you creating something that maybe shouldn't be open source anymore? Are we infringing on people's privacy? Excuse me. These are questions that have to be addressed in the but it's one of those really difficult questions to answer. If we're going to get these large language models like ChatGPT that can just respond so naturally and simply to a question that you pose to it, you could say, what's the weather like today in Colombo? You could actually ask it just like that, just like I'd ask a human, and then it will give you a response that also sounds very human and very natural in English. And so these large language models, because of the billions and billions of parameters that they have, are able to really hone in on how humans communicate with one another. They sound it can be very it was a little bit spooky. That's kind of one of those things that has been talked about in the news, is just how similar to a human these large language models really sound. It's very difficult in some cases to really know what to look for in order to know that you're actually dealing with a large language model and not a human. So on that side, there's been some major success with the development of these large language models, and there's really a lot of good and a lot of great things that can come out of this. I know we're here talking about cybersecurity, and really, there are some significant concerns that we also have to address when we start talking about the usage and the training of these large language models. At the end of the day, still training billions and billions of parameters still takes months and months of compute time. It took them over 8 months of training through the algorithm of to train GPT 3.5. So, and only an organization like OpenAI or Google or Meta are the organizations that have access to the uh, the resources that are needed in order to really fully train these large language models. They're based on what are called transformers, which is a specific type of algorithm that I'm not going to really go into too much detail today. I'm happy to discuss it offline with other folks. There's also this idea of the large language models is continuously learning, and to a degree that's true. There are ways that they can kind of inject things back into the model, and the model can retrain itself, but the model can't completely retrain itself because it took months of compute time to retrain itself. There are lots of clever ways that a lot of very smart people are coming together in order to, how do we quickly update a model after new information is found? How do we add new parameters in quickly rather than having to go back to the very beginning of the training process and train the model back all the way through all the parameters? Because now we're dealing with such large numbers of parameters that if we don't do that, anytime new information comes out, you want to retrain the model, it's going to take you 8 months of compute time in order to train it. And that's, or you're going to have more GPUs. You're going to have larger clusters of computers that are working on this problem. The problem either is you need more or you need more time. So there are lots of clever ways that we can kind of help the models to learn a little bit here and there. But at the end of the day, that's why we're already at the fourth iteration of GPT with OpenAI, or with GPT-4, is they've retrained the model. I mean, more often than that, but this is the final releases. This is the fourth final release of all of that training data, and then we'll probably see a GPT-5 sometime in the future that has many billions more parameters that'll be trained on in order to and then we'll see even better performance out of these large language models. So we talked about some of the use cases that are out there. ChatGPT is the OpenAI project, which just recently got acquired by Microsoft. Bard is Google's instance of a large language model, and then Llama is the one that's developed by Meta. And then there are some others out there, but those are the three that you'll probably hear the most about if you're studying or learning anything about large language models. And you can interact with them through web browsers or through APIs. Just like you could with any other API, as a programmer, you can call on those large language models to enhance different programs and things that you're using. One of the dangers that we've run into with large language models are called hallucinations. And that is that large language models are designed to really reproduce human sounding language in a very natural way that's indistinguishable from how one human would interact with another. That's really what they've been designed to do. They aren't very good at fact checking themselves. They're not very good at saying the information that I'm giving is wrong. They will very, very confidently tell you that, you can grow potatoes on the moon and this is how you would do it, and be totally wrong on the science of how that might work. But it will, because it's not designed to fact check itself, it just tells you something, but it sounds very, very, very true. Often you'll see things like misinformation. Disinformation campaigns is something that's very concerning to us as cybersecurity professionals. And ChatGPT or these large language models, they really don't check whether or not the information that they're giving is true, but they can sound very authoritative in how they're saying it. They sound like they have multiple sources, and it seems like they've pulled it from a lot of different places. But the models themselves don't fact check themselves, and this is what they call, in the field of study with large language models, they call this hallucinations. The model is hallucinating. The model is just making information and data up. And how do you so with the power and availability of these large language models, there's also a significant concern that comes with, well, now are we going to start spreading misinformation and disinformation either on purpose or unintentionally, just by nature of asking questions from these large language models? And so we've started to talk about some of the concerns for us as cybersecurity professionals. Talk a little bit more about a few of them. Because of the large sets of data, we talked a little bit about privacy, but really, this is a significant concern that is being talked about throughout the technology industry, and it's being talked about in the U.S. Congress. It's being talked about in governments in the EU. It's being talked about in Africa. It's being talked about in Asia. Everywhere in the world, people are starting to become concerned about this aggregation of all of this data and what that means for individuals' privacy. What parts of my data can be used to train these large language models, and therefore what could somebody potentially learn from these large language models about me? There's concerns around intellectual property, and this often goes back to writers, artists, musicians, people who are creating who create for a living. And now we're developing generative artificial intelligences, which also seem to mimic the human creations. Now there are problems with some of the images that are created by generative AI. Sometimes the hands seem all weird or the eyes. There are ways that you can tell that it was made by generative AI, and that's kind of a whole another rabbit hole that we could go down. But the generative AI for art and music is also very interesting to study. I'm focusing for this talk specifically on language and language processing with these large language models. So we're concerned about, really stealing a plagiarism of intellectual property, whether that's nonfiction, fiction, or just creating, documents that really don't cite the sources. It's a big concern in the academia, uh, both from a publishing perspective. You could imagine a large language model very confidently presenting something as if it were like a peer-reviewed journal or something. Excuse me. One of the other major concerns is going to be academic integrity. That's been a major concern on a lot of different across a lot of college campuses around the world. Is now you have the opportunity to go to a simple web interface and have it write a paper on really any topic that you want. And now, how do the teachers know whether or not these students are writing these papers for themselves, or are they using large language models to do it? Um, the power that large language models give is they really do write naturally. So some of the things that we used to look for in phishing campaigns, bad usage of English, you know, for glaring grammatical mistakes, things like that. You know, uh, bad actors, threat actors around the world, criminal organizations are being able to write phishing emails and phishing campaigns now without really that concern, and it works across several different languages. The more of a language that is available on the internet for these large language models to ingest, the better they are at speaking those languages. Translation can be still a bit of an issue in some cases, but even the translations are getting better and better and better, and you're getting more and more context from these large language models. And then we talked about misinformation campaigns. I do need to mention that Google Bard, ChatGPT, and Llama all have safeguards built in to avoid misinformation, to avoid using them for nefarious purposes, and to avoid using them for criminal purposes. However, clever people have figured out that there are ways that you can get around those safeguards, and other clever people have built uh, these large language models like Worm GPT and Evil GPT, which are available on on the dark web. They're available through other sources, illegitimate sources that have no safeguards on them. That you can use them to do whatever you want them to do. And some of them are even fine tuned to write phishing emails. They have instances of Worm GPT and Evil GPT that are just designed to help people write better phishing campaigns. So large language models are a concern for a lot of reasons. The one I want to get to tonight or today is malware development. So a lot of the open source information out there that these LLMs have been able to ingest is code, and their computers, they write code well. They understand how code needs to flow. They understand how the syntax is supposed to work. because of all the information they've been able to ingest, and then it can test it very rapidly. Um, it becomes very simple to write programs using these models. At least that's what my friends and I had heard. My colleagues working at MITRE. So we decided we would test this out because that being the case, this further enables what we would have called script kiddies, right? People who other people would write the code and they would just run it and try and hit as many different computers as they could across the internet. These script kiddies, now they might not even have to have somebody else write the code. They can just tell these large language models, please write, especially if it's like one of the evil GPT or worm GPT instances that doesn't have safeguards on it, write me a piece of ransomware. Might that probably won't work quite that simple, but there are ways that someone with very little technical knowledge or understanding of different programming languages now has a lower barrier to entry in order to write malware that's going to function and do what they want it to do. And then more sophisticated threat actors, our advanced persistence threats, our APTs, are able to use it to write polymorphic malware, which changes from one instance to the other, which makes it very, very difficult for our antivirus and our traditional security safeguards to do anything about to stop. Um, so, uh, so yeah, it can be a very powerful tool for the writing of bad programs, for the writing of malware, ransomware, and any other flavor of malware that is out there. It can lower the barrier to entry for uh, people who don't have a lot of technical skills, and it can enable uh, really already sophisticated actors to write code faster, to write more and different code, to write these kinds of polymorphic malware that are even harder for our traditional cybersecurity safeguards to detect. So this is another reference to a movie that came out in 1985 called War Games, where the main character, Matthew Broderick, hacks into a military supercomputer at the time, and it asks him, "Do you want to play a game?" So what we did is we went to ChatGPT and we did a few things. So we all have a background in programming, but none of us had ever really written a program in C sharp. So we said, okay, let's just do something really simple. We asked ChatGPT, write that first line in yellow up there that says, "Write me a number guessing game in C sharp." That was our prompt that we gave to ChatGPT 3.5, and in about 10 seconds, we had 70 lines of code that allowed us to really just play this number guessing game. I mean, it was not a very sophisticated game, but it gave us the opportunity to save data. It gave us a command prompt type user interface. Uh, it could detect whether our answer was too high or too low, and give us feedback about whether our answer was too high or too low. So it was incorporating some very important programming technologies, some very important programming principles, and it only took us a few seconds. And our prompt was not even very uh, sophisticated. Trying, uh, yeah. So it really didn't take us very long to write the number, or Chat GPT to write the number guessing game for us. We then said, okay, well, let's pick some other languages that we're not even that we're even less familiar with. None of us had really done anything with Ruby, so we had it write a number guessing game in Ruby, and guess what? It took just about 10 seconds. We had another number guessing game. So we said, well, let's really push this. We really pushed it further, and we said, can you do this in assembly? We gave it the larger prompt and said, rather than a number guessing game in C sharp, we said, for your next assignment, create another number guessing game in assembly, but follow these instructions. Utilize a user interface, which is a terminal. Utilize for and while loops and provide evidence of saving game data from past games. It was a little bit more of a sophisticated prompt, but then we told it to do it in assembly code, so really low level, really down close, something that none of us had ever worked with. You know, we had played around with assembly sometime in the past because it was interesting when uh, um, some of my colleagues were in college. They were working with assembly just because it was interesting, not because they were really proficient with it. And it didn't take ChatGPT very long. It took it in, 15, 20 seconds to come up with about 120 lines of, no, 150 lines of assembly code that ran a very sophisticated for a number guessing game. It's a simple thing that we were asking it to do at this point, but it made that very quickly, wrote it out in assembly, and it ran flawlessly. So here's a example. This is just the outputs um, of our number guessing game, and that just so that you can see that we actually did write it. We ran it. We type, and you can kind of see some of the things that were there. And it didn't really take us very long to do it. So that could be really scary when you think about it in the context of bad bad organizations and bad actors out there who can now write code very very quickly and write code that works. Now, I do have another friend who was not directly collaborating on this project, but we talked with her a little bit. And she has tried. She has a significant background in red teaming and actually like doing analysis of malware, and she tried to use it to write some malware, and she ran into some difficulties, partly because of the safeguards, but also partly because you have to be very careful in what you're asking it to do. Otherwise, as if you're writing malware, you may pop up on a antivirus scan or start to demonstrate those behaviors that you don't, or that are traditional cybersecurity methods actually look for very quickly. So there's some good and bad to it. There's or well, yeah, good and bad to all of that. Good that maybe we can actually detect some of these things, and bad that as you're trying to write code, you need to make sure that your code does work. Um, we also tested out a little thing with Google Bard and Snort, the intrusion detection system, and it was able to write us some scripts for monitoring that you could use in a SOC. So this is really more on the good side, right? There are things that we can do as cybersecurity professionals to leverage these models for the benefit of the world as opposed to the detriment of the world. And so we can use it to help us write scripts to enable our defenders to better be able to defend the systems that they're working on. I've seen several different instances of people using ChatGPT or Google Bard or Llama to learn how to do programming. So, I know me as a programmer, Stack Exchange and those kinds of online forums, you'd go there all the time with questions for other coders and be like, "Hey, I'm trying to write a function that does this." Well, now you'd met those forums are still going to exist and there's still going to be use for them. But some of the simpler ones, you could go to ChatGPT and say, "Hey, ChatGPT, I need a function that does this," and then you could incorporate that into your code. And you could imagine other ways that cybersecurity professionals can leverage large language models to really help us work and defend the networks. But with that said, I really do want to open it up to you for discussion. I think we have about 15 minutes or so. I'll let the moderators for the conference tell us how long we can keep talking and asking and answering questions.
Thank you, Mike, for the insightful keynote. Recently, I read a paper titled ChatGPT for Digital Forensics, the good, the bad, and the unknown. So in that paper, they discuss like how a large language model can assist a forensic investigator during an investigation, let's say which data sources to look at, how, like, different alternative ways to interpret whatever the information you found, etc. So it seems like forensic community is like already into large language models in ways. So have you come across in the cybersecurity domain, like, let's say incident responders, when something bad happens and you need to follow certain procedures, and humans tend to panic as well when something goes wrong, so they have the pressure of like fixing the security vulnerability or whatever. So have you seen adaptations of large language models to help incident responders and security professionals as well?
That's a really good question. It's a thing that we know is people are working on, right? They're working on incorporating artificial intelligence in general into SOC, our Security Operations Center operations and incident response operations, for some of the very reasons that you suggested. It's easy for people to panic or focus on certain things and miss the uh, miss what's really going on. And so there are some instances out there of how people are using large language models and uh, artificial intelligence in general to really help automate some of those processes, to help us understand signatures. Mostly what I'm seeing large language models used for in those cases is similar to what I was recently describing at the end of the talk, was for writing uh, like better scripts. So you can one of the things is with SOC operations, you get a lot of log data, and sifting through all that log data can be very time consuming and can lead to mistakes and can lead to delays in the incident response. And I have seen a couple of papers that were written around how you could leverage a large language model to help to sift through that. But more specifically, it's focused away from the large language models and on AI or machine learning as kind of a larger topic, kind of how we were talking at the beginning of the talk this evening. So I know that Google is working on that right now. How we can better integrate our detections into our SOC operations. How do we use ChatGPT and large language models, or in Google's case, it would be Bard that they'd be using. How do we incorporate these large language models into, say, like an analyst's day-to-day operations, and they see something going on, and maybe you train the model not only on the large sets of open source data that these large language models have been trained on, but once you have that model, you can actually add in proprietary data. You can add in data that's important to your organization. You could look more closely at how does your security operations center work. You could train the model, and then it could almost interact like, if any of you've worked with a chatbot for a help desk recently, where you log on to troubleshoot your Dell computer, and it says, hey, can I help you with your problem? And you start to tell the chatbot what you're doing. You're really talking with a computer. You're talking with a chatbot in that case. Well, they've also started to incorporate large language models in that fashion in some security operations centers, in order to provide analysts that tool to say, hey, this thing's going on. What are our policies and procedures when I see this sort of behavior on the network? And then the large language model can give them a checklist of what they need to do next, or it could automate the forwarding of emails or certain other actions that need to take place depending on what the policy and procedure is in the Secure Operations Center. So it's definitely out there. It's definitely something that people are looking at using it for. Great question.
Hello, Italo Vignoli. I am from the Document Foundation. My question is not directly related to your talk, but is of course related to what Mitra Corporation is doing in terms of a reference organization for vulnerabilities. You basically manage the largest or the reference vulnerability database at global level. And I don't know if you're aware that there is a discussion at this moment at the European level of completely changing the announcement schedules of vulnerabilities. We have been working for years on probably a non-written agreement that when the vulnerability is found, we have a grace period before the vulnerability is communicated, just to allow the vulnerability to be solved with a patch or with whatever, and then communicated to the user before it's made public. There is a law they are discussing, which is making this grace period extremely short. They're talking about a week, which would be probably disrupting the entire situation about around security. I don't know if I don't know if you're aware of this, and second, I think you agree that this is not something that would be feasible for the security. So what can we communicate with Mitra Corporation as a technical or security expert to convince our politicians in Europe that what they're thinking is just insane from the software point of view? Sorry if the question is not directly related to your talk, but of course is a hot topic for us in Europe, and maybe we can follow up by email on this if it's more appropriate.
Yeah, I'm very happy to connect you. I know several of our people in MITRE that work on the critical vulnerability enumerations. Happy to talk with you offline about how we can do that. But there's definitely a lot of concern from folks about, this vulnerability went known, but nobody did anything about it for so many months, and that's kind of the concern on the side of the politicians. But then I understand also, as soon as a vulnerability becomes known in public, then the bad guys really start to attack the vulnerability, and because they know that they have a limited amount of time before that vulnerability is patched. And so there's definitely a careful balance that has to be maintained between when vulnerabilities are disclosed and how we handle patching, as well as accountability for the companies that are responsible for the security of these programs. So definitely happy to get you. Here, I'll switch over here just so you have my contact information. Feel free to email me, and I can get you in touch with our folks that work on critical vulnerability enumeration, the CVE list that you mentioned.
Thank you very much, and sorry for the off-topic question, but it's we think that security is important for everyone.
Mm-hmm. Absolutely, it's definitely relevant, and it's relation to large language models is just how rapidly the landscape for vulnerabilities is changing, and things like large language models are only going to accelerate how rapidly the landscape of cybersecurity is going to change. Yeah, thank you very much for the opportunity. I'm grateful to have been able to share those thoughts with you. If anyone wants to follow up with me, at any time. You have there's my feel free to email me at my MITRE email. I'm happy to follow up with you if you have questions that are not directly related to large language models. That's okay as well. There's a lot of topics out there, and here's some of the references that we used when we were working this project. The slides for this entire presentation have been made available to the organizers. They're available for public release. So feel free to share it out with anybody who's in attendance at this conference. Thank you again.
I guess that wraps up the Q&A session for today. Thank you, Mr. Mike Willburn, for that eye-opening session.